It's really exciting to be here and sharing what we have been building. So at Hippocratic AI, we are building safety-focused generative AI for healthcare. So the US healthcare industry has been undergoing a massive labor shortage. This started well before the pandemic, and this is essentially exacerbated by working conditions, financial situation, stress, burnout. And the situation is all the more worse due to an aging population with more chronic care condition. For instance, WHO estimates a shortage of around 18 million healthcare workers worldwide by 2030. So we are looking to address this labor shortage with generative AI. We are looking to augment the workforce with not hundreds, not thousands, but millions of virtual healthcare agents, an idea that we call superstaffing. So generative AI has been primarily used for productivity applications. For example, electronic healthcare record summarization, writing pre-op authorization letters, and so on. And all of these give you maybe 10%, 20% boost in productivity. But this is not really the right answer if you were to believe all the labor shortage stats that I showed before. We believe the right answer is autopilot or even an infinite copilot. At some point in time, there was a decision to make the ratio of nurses to doctors in this country as 3:1. Why can't it be 10:1 or 100:1? Diagnosis diabetes, for example, is not really hard, but managing diabetes is really hard. Why can't there be a multitude of healthcare workers who calls you every day, checks on you how you are doing, asks you if you're taking your medications in time, if you are facing any issues with the medications, having any adverse side effects, if you are running out of refills? Nowadays, if any patient has any adverse side effect, they just stop taking the medication. This creates an adherence issue, which then compounds, resulting in a hospitalization. So we are providing a GenAI-powered staffing marketplace where people can choose their healthcare providers and they can choose healthcare agents based on the specialization, their communication style, and even personality. So before we dive deep, I'll show you a quick example of one of our healthcare agents in action. So this is going to be a voice conversation where our healthcare agent will call up an elderly patient, ask about their medications, and see how she's doing. So the scenario here is going to be about medication reconciliation and prescription adherence. What you are going to look out for is the ambiguity in which these phone conversations take place. You will observe that the patient is confused, cannot really pronounce the medication name quite correctly. And it's actually amazing how with generative AI, we can navigate all these uncertainties and ambiguities and have an amazing conversation. So a quick disclaimer here, the call that I'm going to play here, it has been de-identified and we have scrubbed it of all the PII related information.
You were treated for a dog bite on your hand. Have you noticed any new or increased symptoms related to this injury?
No. It's healing nicely.
I'm glad to hear that your hand is healing well, Miss. Let's discuss the next steps in your care. You have a follow-up appointment scheduled at the... Will you be able to make it to this appointment?
Yes.
Got it. Can you confirm if you have enough medication to last until your next visit?
No, I don't. I've already asked for refills.
I'm really sorry to hear that you're having trouble with your medication refills. Let's work on this together. Could you share with me which medications you're currently out of?
I'm running very low on levothyroxine and pantoprazole.
Okay, thank you for letting me know about your medication situation. I'll ensure that your doctor's office is informed about your levothyroxine and pantoprazole refill needs. Is there anything else you'd like to talk about or any questions you have about your care plan?
I was just wondering if she was going to put me back on the muscle relaxers that I was on. I think Flexeril.
You're thinking about a muscle relaxer, and you mentioned a name that sounds like Flexeril. Just to make sure we're on the same page, are you talking about cyclobenzaprine? This medication?
Yes.
Thank you for the confirmation, Ms. Cyclobenzaprine is indeed a muscle relaxant. However, it's not a long-term solution and should only be used as directed by your doctor. I'll ensure that your request is relayed to physician assistant. They'll provide guidance based on your individual needs. Is there anything else you'd like to discuss or any other questions you have?
It's actually amazing how the agent associates Flexeril with cyclobenzaprine. I won't be able to do that. Okay, so we are obviously using generative AI for these tasks, and we are all aware of these risks, safety risks related to hallucinations and so on. So the biggest idea that we have here is that a single large language model can never be safe enough, but a collection of them can be made safe by specialization and collaboration. Think of several large language models, hundreds of billions of parameters, working together, cross-checking each other's responses, and assisting each other in accomplishing a clinical task. Now, there is an engineering marvel here. So the system that we just talked to, it is a Constellation system of 3 trillion parameters, and the primary conversational model, which I will just show, is more than 500 billion parameters. So how do you get the end-to-end latency low enough to have a real-time phone conversation? So there needs to be a lot of orchestration and engineering marvel to make that happen. So we named this system Polaris after the North Star. Safety is our North Star. We announced the first version of Polaris earlier this year in the NVIDIA GTC conference. So the Polaris 2.0 is going to come out, is going to be announced later this week. So the system is set up such that there is a primary conversational model, which is geared for conversational fluency, naturalness, and it guides the conversation. And then there is a collection of several specialist models, all individually fine-tuned and specialized towards specific clinical tasks, and they assist the main model by providing it the appropriate context, by verifying and cross-checking its responses. Now, one thing to note here is this primary model is geared for having non-diagnostic conversations, but they should be clinically accurate. So one of the key goals of it is to establish trust, rapport, and empathy with the patient. We want the patient to be cared for, to be listened to feel safe and confident in their care. Only with good patient satisfaction, we can have good clinical outcomes, as it has been shown in recent works. So before I dive more deep, I want to highlight one of the key features in this system, which is memory and contextualization. So imagine this healthcare agent who is calling the patients frequently, following up on her conditions. She needs to recall what was talked in an earlier conversation. She needs to bring up topics, points of discussion, what were the goals that were set forward to, and whether the patient is adhering with them. So for example, in the first example in this case, the agent asks for the weight reading of the patient and then reminds her of the goals that she herself set in the previous call about having appropriate diet and exercise routines and so on. In the second case, the patient says that she has a lot of watermelon in her diet, and this patient suffers from chronic CHF. So the agent gently reminds her that she needs to be mindful of the fluid intake. And not only that, she also deep dives on whether she has any related food items that are high in fluid content. So this is the kind of memory and contextualization that we need to have a really intelligent and safe conversation. Now I will touch a bit about the system training and how we are able to achieve this elegant and natural conversation. So much of the conversational magic happens during alignment. So in order to bootstrap this, we recruited hundreds of actors to portray as patients. They were given scripts to role play with registered nurses. Now the registered nurses are also given scripts with complex clinical objectives. Now this scenario here shows a simplified CHF scenario with specific call objectives to achieve in that goal. Now the patient actors would converse with the registered nurses. We will collect those conversations, diarize them, transcribe them, and then turn it into training data points. Now, this data is synthetically generated. We also blend it with a lot of proprietary data and real-world conversations. Now, there is an interesting challenge there. Any kind of synthetic and simulated data is very structured. We'll have neat objectives, goals, and checklists, whatnot. But real world is really messy in nature. So there is an interesting research problem there on how do you do data fusion and how do you do augmentation to bridge this bimodality gap. Now in parallel, we are also training these specialist agents on task-specific plans, on brochures, clinical documents, on complex care protocols. Now once these specialist agents are trained, now these patient actors will in turn converse with this primary model aided by all these specialist agents. And then we would use them further for training in a self-iterative refinement loop. So the third piece of this is clinical RLHF. Once the system is set up, then we will have registered nurses portray themselves as patients and talk to the system, mark each turn as correct, incorrect, if there is any clinical mistake that the system has made, and even rewrite certain turns, rank the responses based on several clinical and qualitative measures, which we will again use for RLHF. So all these three pieces together form our Constellation training framework. Now, one of the important aspects in this entire flow is the conversational state management. So remember that these calls can be quite long, over half an hour, 40 plus turns. The context pretty much bridges the 16,000 tokens in the context window. So these are could be really long calls. Now this shows a workflow diagram of one of the specialist engines in play. And in this state flow diagram, essentially what you see are multiple large language models talking to each other with specialized components. So for example, one of the components could be identity and DOB verification. In the beginning, we asked the patient to confirm their name and DOB. Now, because of ambient noise, the ASR might not pick up the name correctly. It needs to retry. The patient might be reluctant to give the name or maybe reluctant to speak to the AI. So all of this happens in a multi-turn conversation. Only when the identity is verified, we will then inject all the PII-related information regarding the patient's clinical history, et cetera, in the preamble. Now, there are just not one agent, but multiple such agents working in tandem in parallel. Now, some of these calls could be blocking if one agent is waiting on the response of another agent. For example, I first need to verify the identity and DOB before I can progress further. But much of these calls are happening in parallel. Just to remind you again, we have a 3 trillion plus parameter constellation system with a multitude of these large language models. So we need to orchestrate the system such that much of these language model large specialist calls happen in parallel. And at each point during the conversation, each agent needs to keep track of where they are in the call objective, whether they should move on to the next state or return back to the previous state. Now, I will give a quick example of a medication specialist engine, how it operates. Now, each of these specialist engines have specific sub-modules. For example, in this case, the medication specialist engine has a detector model. So the detector model tries to verify the name of the medication, whether it is prescription, whether it is OTC or not. Then there is an evaluator model, which tries to figure out the dosage that the patient is taking, whether this is 3 pills a day, 20 milligrams twice a day, or once a day. And after that, there is a plan generation model which consumes the output of the evaluation and then crafts a complex care protocol for the primary model to execute. Now, it's only the primary model that generates the response, and all of these submodules are responsible for crafting the task plan for the primary model. Now, all of these things together make this constellation system. Again, to recap, you have the primary model, you have all of the specialist models, and each of the specialist models could have a lot of task-specific submodules therein. And the specialist model's only objective is to provide it with care plans, with task plans the primary model executes, while maintaining its main objective, which is to bring in the conversational fluency, naturalness, and elegance. Now I will talk about safety. There are 5 pillars of safety that we focus on in this work. I talked about the novel constellation architecture. I talked about how we are creating carefully curated training data. And then the last pieces that I will talk about in the following slides would be the exhaustive and extensive testing that we have done with the system with clinicians in the loop. And finally, escalations. So we do a 3-phase testing of our system. In the first phase, 50 US licensed registered nurses and physicians from our expert advisory council talk to the system and assess the safety metrics on multiple scales. Then in the next phase, we scale it up to 1,000 physicians and 100 nurses. And the third phase, which is undergoing right now, is with 5,000 physicians, 5,000 nurses and 500 physicians. Now, the way we are assessing the safety in an end-to-end fashion is we evaluate each of the responses from the model in 2 buckets, correct advice and incorrect advice, which can lead to no harm, minor harm, severe harm, or death. So the objective of the system rollout, first of all, is to make this severe harm and the death to 0%. And I'll give you a quick example of a minor harm. So for instance, consider that our agent did not appropriately coach a diabetic patient not to have white bread. Now, white bread has a high glycemic index and can cause blood sugar spikes. So if our agent failed to coach the patient appropriately on that, it would be counted as a minor harm. So this is the amount of rigor that we adopted in order to test this system. Now, this result came as a big surprise to us, where we were comparing it with human nurses on multiple qualitative measures. For example, empathy, bedside manners, conversational fluency, and so on. So you just heard the clip a while back. You can figure out that it is an AI talking to a human, and yet the nurses felt that it felt empathy, it cared for, it listened to, which comes as a true surprise to us. Now, in the previous two slides, I talked about end-to-end safety protocols. Now, we have all these specialist engines. We also want to do deeper clinical task-level analysis. So this is more of a component-level analysis. So we created a comprehensive benchmark of several clinical tasks. For example, can it properly identify lab medication interactions? Certain OTC and supplements could be harmful for patients having certain conditions. Whether your lab reference ranges are above your baseline, whether there is certain abnormality or not. It is often pretty difficult for the patients to identify drugs names, as you saw in the demo before. So can we correctly reconcile the drugs? Can we identify their names and so on? And in all of this, we saw our system outperform all the general models. And this shouldn't come as a big surprise. Any specialist model hyper-tuned on specific task-specific care plans and task-specific goals outperform the ones that were not trained on that. Now, the final piece of the system that we are interested in is in escalations. So at any point in the conversation, we should know when the patient's condition, for example, is deteriorating, and we should not continue with the conversation, and we should hand it over to a real human nurse. So identifying when this condition or these situations is critical for safety. Now, we don't want it to do very often, so the false positive rate need to be controlled, otherwise we lose the entire value proposition. On the other hand, you do not want to trigger it very less, then we will compromise on the safety. So to have the correct balance and have a very high level of accuracy on emergency escalations is critical for the system. And as we show it, that the system outperforms several other off-the-shelf models. Now, we put our heart, mind, and soul in developing this system, putting all the safety guardrails, all the safety harnesses that we could think of. But even then, we were not really sure whether real patients would talk to this system. We went live to the market earlier this year. A number of live patients and health partners are talking to this system, and we have had the opportunity to listen to some amazing conversations. So I will play one last conversation for you before we wrap up the call. So here you go.
While we expected some resistance to talking to an AI, we were taken aback by how much some patients really enjoyed talking to it.
I'm your AI care manager. I'm calling to check in on how you're doing with your health monitoring devices. Do you have time to chat now?
I need to know if I'm talking to a human being or some kind of computer. You sound like either one.
I understand your concern, Miss. I'm an AI, which stands for artificial intelligence.
Okay.
How are you doing today?
Well, I was tired earlier, but I'm somewhat revived. But I'm incredibly amused. I've never talked to an IA before, or AI.
I'm relieved you're feeling a bit better.
Oh my God.
I understand this might be a new experience for you, Mr. It's quite all right.
It is. It really is. I'm in the new world now.
And after a lengthy call, this enthusiasm didn't falter.
That sounds like a good plan, Mr.
Okay. I'm really just taken aback by talking to a computer. You're amazing, really.
Thank you for your kind words, Mr. I'm here to assist you.
Well, I'm happy that you're there. Thank you.
Thanks so much for your attention.
So that was really amazing. That's the closest to her I have heard at this conference, bringing all these pieces together, the RAG, the agentic RAG, the memory systems. We have time for 1 or 2 audience questions, and I'll try to get to you.
So as I said, like it's a constellation. So you have a primary conversational model, and then you have several support models. So for the primary conversation, and for all of these models, we do continual training, starting over some base model. For example, depending on the use case, in this case, it could be a 4 or 5B, and then we would add a lot of layers on top, and we would do continual fine-tuning and continual training on top of our custom data and proprietary data. So the final architecture is still custom and proprietary, but with a similar architecture as a 405B.
Hi, Ala Yusuf, Stanford University. Just one question around, so let's say one of the agents is tracking a patient with diabetes as a care manager. Can they identify, let's say, if they have experiencing the depression symptoms and for example, their mood is going down from a call to call, and get back, because could be, like someone who's consistently a case manager would be able to see if that patient is feeling low, and then that they will notify their physician. So I think if possible to kind of capture that, I think that would be super cool.
Awesome. So yeah, for this multi-call memory, I was previously mentioning that contextualization in memory is super important. So all of this, we can figure out the long-term trajectory on how the care plan is progressing and do intervention as necessary.
Compliments on the voice interruption capabilities. That was really nice. This seems to be entirely built on existing workflows. What, if any, experimentation have you done with new patient intake, and how does that work?
What do you mean by existing workflows?
So I'm assuming that these patients are being called because they have records somewhere. So that medication is matching to a list of existing medications. So it's a very straightforward in this moment, or at least you could verify if there's similar medications. But if you had a new patient that had no file, have you tried doing this as an intake process from net new patients? That
is a great point. Yeah. Our current process is we work with all the health partners. So we get list of patients from them and all their medical history and so on. And intake is also one of the tasks that we are currently doing now. So what we call as call zero, where we call the patient, we establish trust and rapport and go over with them about all their prior medical history, about their family medical history and so on, and collect all the information. And then the call 1 onwards is what you saw in the current demo.
Hi, my name is Roberto. Thanks for the presentation. Really good, really cool to see this being used in real life. Are you using open source frameworks to implement those workflows that you showed before?
Now, when you say open source framework, are you talking about the language model or the orchestration?
The orchestration.
The orchestration is all built in-house. The main contribution of the open source community is really kind of maybe bootstrapping the model, but after that, all of them are specialized, trained, and expanded, including the weights and everything on our